Now, it's logical to assume if we're going to convert from decimal to degrees, minutes, seconds with an angle, we should also be able to go in the other direction. So if I had 35 degrees, 23 minutes, and 15 seconds, how would I change that into just a decimal measure of degrees? Well, the 35 is the easy part. The 23 is out of 60 because there are 60 minutes in 1 degree. And then I can say 15 seconds, well, to get to degrees, that's actually going to be 60 squared. So if I plug that into a calculator or just did the work on my own, I would end up getting 35.3875 degrees. Oftentimes it's easier to represent things in terms of just a decimal version of degrees, but you will see both regular degrees and degrees, minutes, seconds. Okay. Now that leads us to the next form of how to measure an angle, and that's radians. The higher you go up in math, the more often radians are used. And I always think it's interesting to know the true definition of a radian. How did they come up with this? 1 radian is the measure of the central angle whose arc is the same length as the radius. You say, what? If I have a circle like this, the angle that's going to give me something that allows this arc to be the same measure is the radius. That's always going to be 1 radian in measure. So of course the logical question that I have is, how many radians are there in a full circle? Well, partially you know this already by how you calculated the circumference of a circle. If I know that this radius is r, the circumference of a circle is equal to 2 pi times r, or some of you would say pi times diameter. But just in terms of radius, it would be 2 pi r. So, if I have how many of those r's in one circle? Well, 2 pi radians is equal to 1 circle, or 360 degrees. And that makes for very convenient conversions that we can do. So, if I divided both sides by 2, I could also say that pi radians is equal to 180 degrees. That's usually the conversion that's most often used. But to me, if you remember the formula of 2 pi radians for a circle, that's good too. So let's say we needed to convert 135 degrees into radians. Well, again, a unit conversion, I would say that pi radians is equal to 180 degrees. Notice degrees goes on the bottom here because it's going to cancel with the degrees here. And let's see, that's divisible by 45, that's divisible by 45. 45 goes into this 3 times, 45 goes into that 4 times. The degree symbols will actually cancel, so 135 degrees is equal to 3/4 pi radians. If an angle is ever written without units, it is assumed to be in radians. Okay. What about going in the other direction? If I have 5/6 pi radians, and I want to change that into degrees, I just have to flip things. I put pi radians here, 180 degrees here, radians and radians cancels. Pi and pi cancels. The 6 and the 180 would cancel to give me a 30, and that would be equal to 150 degrees. This is a very important conversion and something that you commonly do in different aspects of trigonometry.